Hello friends, welcome to Learners Forum. This video is about the next topic, which is star and delta connection. So first let us see the individual connection of how a star is going to be and how a delta is going to be, and then let us convert the given star into its equivalent delta and convert delta into its equivalent star, and let us analyze the formulas for the conversion. So first, when we consider a star connection, similar ends of three resistance are connected in a common point. So that point is called as a star point or a neutral point. So if you consider these three resistances, similar ends, that is the same ends of the three resistances. So if we consider the first resistance, the end is taken here, and similarly for the other two resistances, the similar ends are connected together where we have a common point. So this point is called as the star point or the neutral point N, and it is also called as Y connection or T connection because of the shape formed over here. So the same star can be represented in this particular structure, that is in shape of T also. So that is why it is called as T connection. So here also we have connected all the similar ends of the three resistances in meeting at a common point. So this is also considered as an equivalent star. So this is the basic star connection. Now let us see what is the delta connection. So in delta connection, the dissimilar ends of three resistances are connected together. So if you consider the three resistor available here we have taken the end of one resistor, whereas for this particular resistor the other end is chosen, that is the dissimilar ends are connected together in this particular condition where we have formed a delta, that is a mesh or a closed connection. So that is why it is called as a delta connection, which means the symbol of delta is in this particular triangle. So this is equivalent to this particular structure, and that is why it is called as delta connection, or you can call this particular connection as a pi connection also. Here also we have connected the dissimilar ends and we have formed a pi structure. So that is why it is called as a delta connection or a mesh connection or a pi connection. Mesh in the sense we don't have any other loops inside, we just have a single mesh. So that is why the connection is named this way. And here we don't have any neutral points in the delta connection like we have seen in the star connection. So this is the difference between the star connection and the delta connection. In star connection we will have a neutral point, whereas in delta connection we will not have any neutral point. And there we will have the connections by joining the similar ends, and here we will have the connection by joining the dissimilar ends of three or more resistances. So this is the basic difference between what is a star connection and the delta connection. So the next topic is going to be conversion of the star into its equivalent delta or the equivalent delta into its star. So first let us analyze how to convert delta into a star transformation. So here delta in the sense we will have a triangle like structure, that is a delta like structure, and we have three resistances RAB, RBC and RCA, and the junction points are A, B and C. So to convert this particular structure into its equivalent star, which I have drawn inside the particular delta, so this is the structure we have got over there. So here if you consider the single resistance, we have represented it as RAB. So this will be divided as two things, that is RA and RB, to form the structure. That is, the single branch will be expressed in this particular way. So we have got this particular structure in the equivalent star. Next, similarly for RBC, we will have both RB resistor and RC resistor, which means we have to include this RB and RC forming this particular structure. Next, for RCA, we should include RC and RA resistor. So RC is here, RA is here. So the entire RCA, that is the single resistor here, will be segregated as RC separately and RA separately. So we will have this particular arms lying in this way. So this is the equivalent structure obtained for the given delta. So here we will have RAB, but here we will have RA and RB separately. Likewise, a single branch, that is a single arm, will be expressed as a combination of two branches over here. So here, if we know the value for RAB, RBC and RCA, we have to calculate the value for RA, RB and RC now. So the formula is RA, which is equal to RAB RCA divided by RAB RBC plus RCA, the total resistance. Let me tell a shortcut for this particular formula, that is, if you are going to calculate the value for RA, you have to include all the resistances in terms of RA. For example, we have got three resistances, RA, RBC, RCA. So in terms of A, in the sense we will have both RAB and RCA, where we have this A notation here. So we have to include these two resistances in the numerator. So RAB RCA divided by the total sum of all the resistances. So we have to add all the three resistances in the denominator. Similarly, if we are supposed to calculate the value for RB now, we have to look in for the resistances in terms of RB. So in terms of RB, we will have RAB and RBC but not RCA. So in the numerator, we will have it as RAB into RBC divided by the total resistances. So only the numerator will be getting differed for each values of RA, RB and RC. Similarly for RC, in numerator we will have the resistances in terms of C. So it is RBC into RCA divided by the sum of total resistances, RAB plus RBC plus RCA. So that is the product of adjacent arms of delta. For example, if you are supposed to calculate RA, you have to look at the adjacent arm available here. So here adjacent arm available is RAB1 and we have the adjacent arm other as RAC. So it is RAB into RAC divided by sum of all the arms of delta. So all the arms of the delta, in the sense, the first arm is RAB, second arm RBC, third arm is RCA. So just add all the arms together, so we will get the denominator. So this is the general definition to calculate the value for RA, RB and RC. So this is how we have to convert an equivalent star from the given delta circuit. The most important thing to remember is the position we have chosen over here. So here it is RAB, so you will have the values of RA and RB in this way. Similarly, here it is RBC, so we will have the value of RB and RC. For example, if you put it as RC here and RB here, again you will have to make a change over here, and correspondingly the star network also will have a change. So whenever you are converting a delta network into its equivalent star network, make sure that you follow any one of the notations so that you can remember it easily. So always keep it as A, B, C, so that you will have the equivalent value in the representation in this way. For example, if you are making any change with the notation, then you have to change the formula also accordingly. So it is always better to remember this particular directional notations for the star and the delta networks. Now let us see the next conversion, which is from star to delta conversion. So in star to delta transformation, we will have a star in the circuit now, and this star has to be converted into its equivalent delta. So star will be converted to its delta. We have the star network like RA, RB and RC connected with a common junction point. When we are converting the star into delta, we have to combine these two resistors RA and RB as a single resistor, forming it as RAB. So the dotted line representing here represents the delta network, which is nothing but I have drawn over here again. So RA and RB will be combined as a single network. So we will get it as RAB. Similarly, RB and RC will be combined together, forming a resistor with a value of RBC. And here RC and RA will be combined together to form RCA. So we will get this particular delta network with the equivalent values. So here we have got it as RAB, RBC and RCA. Now we have to calculate the value of RAB, RBC and RCA. So we know the values for what is RA, RB and RC, and we have to identify what is RAB, RBC and RCA. So the formula to calculate the value of RAB is RA plus RB plus RA divided by RC. Again, we have a shortcut for this also, RAB, which means you have to include all the values of resistances separately first and then together, that is multiplied value in the numerator. So we will have RA plus RB plus RA into RB, which is available in the first portion, divided by the third term alone, the remaining resistance value. So here we have got it as AB. So the remaining value is in terms of RC. So that is to be taken in the denominator. So you can express the equation in this way also. The other way to express this, after taking LCM, that is after multiplying RC for the first two terms, we will get it as RA-RC plus RB-RC plus RA into RB divided by RC. That is, you have to take the sum of all the individual resistances available with the other one, that is RA-RC, RB-RC, RA-RB, the combinations of AB, BC and CA, and add it together, divided by, if you are looking for RAB, the remaining resistor value will be RC, that has to be taken in the denominator. Just divide the value by RC. Similarly, if you consider for RBC, which is RB plus RC, that is you have to consider individually for B and C, that is why it is RB plus RC, plus remaining is RB into RC, that is you have to take it together, divided by the leftover element, which is nothing but A, so divided by RA. So this also you can represent in this particular equation, which is nothing but RA RB plus RA RC plus RC RB divided by RA. So the numerator will have the same value, but the denominator alone will get differed for each equation. Similarly, for RCA, it is RC plus RA plus RC into RA divided by RB. You can use any of the equations here. So these equations, after deriving from the equivalent star network only, you will end up at these equations. Here we have seen the equations directly instead of solving for. So the finalized equation is more than enough to solve any problem to convert a star to delta or delta to star. So that is the reason why I have made it very simple. Now let us see problems based on this particular formulas, how to convert a delta to star and star to delta. Example, calculate the value of R for delta network for the given star network. So here we have got a star network and we have to convert this star network into its equivalent delta network. So for star network, we have got the values as RA, RB and RC, and we are supposed to calculate the values of RAB, RBC and RCA. So we have to apply the formulas for converting star to its equivalent delta network, and the formula is to calculate the value of RAB, like we have seen before, it is individual resistance term first RA plus remaining term RB plus product of two terms RA RB divided by the leftover variable, which is RC. So substitute the value of RA, RB and RC now. RA is given as 6 ohms, RB is 18 ohms and RC is 3 ohms. RA is 6 plus RB is 18 plus 6 into 18 divided by RC 3. So simplifying this, we will get it as 24 plus 36, which is equal to 60 ohms. Next, similarly, we can calculate the value for RBC, which is equal to RB plus RC plus RB into RC divided by RA, which is equal to RB is 18, RC is 3 plus 18 into 3 divided by RA is 6. So 6 3s are 18. So we will get it as 21 plus 9, which is equal to 30 ohms. Next, RCA, which is equal to RC plus RA plus RC into RA divided by RB, which is equal to RC is 3 plus RA is 6 plus 3 into 6 divided by RB is 18. So 3 6 are 18, which get cancelled. So it will be 3 plus 6 is 9 plus we have 1 over here. Don't forget that. So 9 plus 1 is 10, which is 10 ohms. So now we have got the values of RAB, RBC and RCA as 60, 30 and 10, with which we can form the delta network. So this is how we have to convert the given star network into its equivalent delta network. Now let us see the opposite conversion also, which is converting a delta network into its equivalent star network. Just assume that we have a delta network with the values as 60, 30 and 10, and now after converting the values into its equivalent star network, we have to get the values of RA, RB and RC. These values we have calculated earlier, that is we have the same problem 6, 18 and 3. Now let us check by applying in the formula. So the value of RA is, we have to include all the resistances with the values of A included here. So we have RAB and RCA resistor in numerator, and in the denominator we have to add all the resistance value, which is RAB plus RBC plus RCA. RAB is 60, RCA is 10, and the total values is 60 plus 10 plus 30, which is equal to 600 by 100 is equal to 6 ohms. So this is the value we have obtained here for RA also. So this is how we have to use the formula and convert as per the question from star to delta or from delta to star, provided we have to make sure that we remember the formulas correctly, because in case if you make a simple change, then the values will be different and this will lead to a wrong answer. So this is all about conversion of star to delta and delta to star network. In case if you have any doubts, you can post it out in the comment section. Thank you so much, friends.